Hi, in this video I'm going to be discussing the ambiguous case of the law of sines. I am assuming that you've already been exposed to the law of sines and you've worked through some problems using the general template. The ambiguous case is isolated to a certain set of conditions, and those conditions include, given the order of the pieces side-side angle, and the angle can be acute or obtuse. We're going to take a look at a couple cases with acute angles, and you'll see from this particular diagram I've drawn the missing piece here would be side A. I'm going to demonstrate that side A can actually connect with B over here, but it can actually hit anywhere on this opposite side. As long as it doesn't map itself straight to A, it will create a triangle, but then again it may not even form a triangle at all, and this is why it's called the ambiguous case, because we have so many different scenarios. So let's just set the stage here. First thing I'm going to do is drop down a perpendicular, creating a right triangle. We would call that the height. Now we know that from the past we should know our sine ratio. If I were going to take this triangle and use angle A and create the sine ratio from that, then I could say that the sine of A is equal to side opposite over hypotenuse, which would be H over B. From that, as you can see from what I've done, I can take cross products and isolate H. So H becomes B sine A. So I'm just going to replace H with B sine A. Next, I'm going to, let's just say I choose a length for side A that is not quite long enough. How will I be able to know that I don't have a triangle? Well, the first thing I'm going to do is I'm going to compare side A with B sine angle A. You'll notice if I swing that arm down that A, if I drop it down, it won't reach the opposite side. So the shortest distance to the opposite side is the height. And so if side A is shorter than the height, or B sine A, then the triangle will not exist. So that's case one. So you'll have to compare side A with B sine A to see if it's long enough. Your second case scenario, again, same set of weather conditions, so to speak, but this time we are going to be able to form a triangle if the side A equals B sine A. Then we definitely have a triangle. It's going to be a right triangle, but it's okay. If side A is longer than side B, then it will also create one triangle. So again, if side A is equal to B sine A, or if side A is greater than or equal to side B, then only one triangle is possible. So now let's take a look at the third case, which is oftentimes the most complex case. Again, the same triangle. This time, however, A is not the shortest piece, and it's not the longest side either. It's right there in the middle. So we would say that B sine A, the height, is the shortest, and side B is the longest, with side A being in the middle. So this is a one case scenario that can occur if side A is in the middle. Or we can swing that arm around and create another triangle. That triangle would have an obtuse angle in it, and this set of condition creates two possible triangles. So if A is not the longest and it's not the shortest, it's in the middle, and side B is the longest, then two triangles do exist, and yes, you must solve both triangles. I know that doesn't thrill some of you, but that's just the case. Alright, now case 4 includes what if you are given an obtuse angle to start with. Well, first of all, there are two situations, and the first situation is you'll never have any options for two triangles, because as you recall from case 3, The second triangle that was created was an obtuse triangle. Well, if you're already starting with an obtuse angle, you can't have two obtuse angles in a triangle. So that would take away the possibility of having two triangles. You can, however, have a situation where the side is not long enough. So if side A is shorter than or equal to side B, then the triangle won't exist. Again, you can swing that arm down and see that when it maps itself to side B, it's not going to form a triangle, it's just going to be a straight line. So again, if side A is less than or equal to side B, then a triangle will not exist. The second case scenario is if A is longer than B, then one triangle will exist. So to wrap this up, how do we approach each problem? Well, first of all, you want to inspect the order of the given pieces. The ambiguous case only applies to triangles with given pieces side-side angle. Draw an accurate diagram. That's crucial. Note if the given angle is acute or obtuse, and if it is obtuse, then compare the lengths of the two given sides as noted on the previous page. If it is acute, then compare the side opposite the given angle to B sine A, as noted on the previous pages. So in the next video, I'm going to go through some examples, but I hope that helps explains why this particular set of this order of numbers creates this ambiguous case.